Welcome back. We've just seen some simple examples of the I/O monad that allows a Haskell program to communicate with the outside world. And the kind of idiom that we emphasized was that we have a sea of imperative code with islands of pure code. And in this part of this lecture, we're going to show a slightly larger example that also features this pattern. So we will have some imperative code that glues the program that we're going to write, the pure program that we're going to write with the outside world, but we're going to use all the nice functions, pure functions that we defined before over lists. We're going to use them here to write the core of our program. And the example that we're going to do is a very simple version of the game of Hangman. And if you have never played Hangman, it's a popular game with kids. And what you do is one person has a secret typed words, and then the other person has to try to guess the word by entering a sequence of guesses. And for each guess, you will see which letters occur, and then, as you go on, you have to guess the word. So kids play this quite a lot, and it's kind of fun. And the hangman part is that you only have a finite number of tries, and you draw a picture, and then at some point you die because you ran out of turns. So the game ends when the word is correct. In this case, we don't draw pictures or try to kind of make you lose. Now let's start writing this code. And what we're going to do is we're going to take a top-down approach where as we go, we will design the parts of the game that we need. But we first start with the interaction with the outside world. So what we do is we print to the output is think of a word, and then we secretly read that word. And this function, secretly getLine, will read a string, but it will echo that string with underscores. And then the computer will ask us to try to guess the word. And then how do we do that? Well, we typed in a word, and then we're going to guess the word, and we will see what that function guess is in the next few slides. First thing I want to show is this function here, secretly getLine, which reads a line of text from the keyboard, echoing each character as a dash, as an underscore. So what do we do? Well, it's a function that reads a string from the standard input, so it has type IOString. And what do we do? Well, we first get the character. If that character is a new line, then we echo the new line, and then we return the empty string. Otherwise, we print an underscore. We recursively, secretly read the rest of the string, and then we return the string that we read. All right? So you can type this code in and try it out in GHCI, and what you will see is that as you type a word, it will show the dashes, and it will return the word that you typed in without revealing what the word was, because it only shows you how many characters there are. The action getChar here, it reads a character without echoing it to the screen. So what we have to do is we have to turn the echoing off, then we read the character, and then we turn the echoing on, and then we actually return the character. So here you see that this is typical imperative code where you write one statement, another statement, another statement, another statement. And one thing to note is that while this looks like an assignment, it is really not an assignment, right? This is just saying This is type IO of char, and you bind it to a character. So there are side effects here, because we're interacting with the environment, but we're not using mutable variables. Haskell does support mutable variables, but we won't discuss them in this lecture. But for that, you have to have a special monad, or you can do it in the IO monad as well, but you have to allocate specifically the mutable variables and write and read from them. And this here is just, because this is a monad, it just takes the value of this computation and binds it to C. So C is not a mutable variable. All right, enough of the IO part. Let's now look at the function guess. So guess is the game loop which requests guesses and then checks whether the guesses are right, and can, until the a user or the player has found the right answer. So let's look at the code. We guess the word. So this word was the secret word that we read. So what we do is we print a prompt on the screen. We read the guess. And then if the word that we typed in was the secret word, we're done. So we say, oh, congratulations, you got it. Otherwise, we compute the difference between the secret word and what the user typed in. We print that difference on the standard output, and we then recursively go and guess the word. And here you see where there's a tail recursion. So this thing here, guess word, calls guess word again. And if you're a kind of lousy player, then like me, you will have to use a lot of turns to do this, and you don't want this to Stack Overflow. And we're now back into the world of pure functions. We're finally left this sea of imperative code, and we've reached the beautiful island of purity. And there we're going to define this function diff, the function that takes two strings, and returns a string that describes their difference. And to define that function, we're going to use a list comprehension. All right, so what we say, we take the two strings, and we're going to check for each character in the first string, for each x in the first string, we say, if that character appears in the second string, then we just return that character. So every character that appears from the first string that appears in the second string, we're just going to return. And all characters from the first string that don't appear in the second string, we're going to return an underscore. So for example, if we take the diff between Haskell and Pascal, then we see that the AS appears here, and the double L appears here because L appears there. But we see it twice because we just look whether L appears in this string, yes, and then we see another L that appears here as well. So it's a very simple diff. It just checks whether the strings, which strings on the left appear on the right. All right, that was the whole game. Happy hacking, and make sure again that you do your exercises and that you play around with the IO monad. And when you write code yourself, no matter whether it's Haskell, C#, Java, F#, Scala, Python, PHP, think about the idea of having a sea of imperative code that interacts with the outside world, and in there have islands of pure code where you write your functions in a pure way. But you have to decide how big the islands are and how big the sea is. But the answer is never that there's only islands or only sea. A good programmer knows exactly the right balance. Great. Thank you, and see you next time.